Lesson 2, Operations of Arithmetic. Some terminology from this lesson. We're going to be looking at the key words that you would have when you're working with different arithmetic problems. So when you're looking at an addition problem, the two numbers that you add together are called the addends. And the answer to every addition problem is called a sum. So if they ever ask you what is the sum of these two numbers, that's a clue that tells you you're supposed to add the numbers. For subtraction, the bigger number you have is the minuend. And what you're subtracting from that number is called the subtrahend. And the answer to all subtraction problems is the difference. So if they ever ask you what is the difference of these two numbers, you take your two numbers and you subtract them. The other operation is multiplication. The two numbers you multiply are called your factors. So when you multiply two numbers, you get an answer, a product. So a product is the answer to a multiplication problem. So if you ever see the word product, means you need to multiply your two numbers. And then we have, for division, we have the dividend. So if you write it as a fraction, fractions are division problems. The dividend is up on top, and the divisor is in the denominator. Or if you think about the division box, the dividend goes in here, and the divisor is on the outside. And the answer to our division problem is a quotient. So if they ever ask you for the quotient, it's the answer to a division problem. And then you have the symbols. So for multiplication, you may use the X. In algebra, normally they use, in higher level math, they'll use a dot. And the reason why they use a dot is because a lot of times you're going to have variables. And so to distinguish between the multiplication sign and a variable, they use the dot. Or you might see a number like here, 3 times 5, the parentheses, and a number right next to it, or a variable right next to it. That just means multiplication. And then for division, you can use a division sign here, you can use the box division sign here, or you can use the division bar sign like a fraction. Let's look at some examples here. What is the quotient when the product of 3 and 6 is divided by the sum of 3 and 6? So there's a lot of words in there. So they're asking what is the quotient? Means what is the answer to a division problem? What am I dividing? Well, they say, what is the quotient when the product? Product means multiplication. What am I multiplying together? Well, it says the product of 3 and 6. So I'm going to write 3 times 6 is divided by, so I'm dividing this by the sum. So sum is addition. What am I adding together? 3 and 6. That is one way of writing it. Or you could write it as a product, so 3 times 6 divided by 3 plus 6. I'm going to put parentheses in here because they want you to take the product, the multiplication problem, and then you have to divide by the sum. So later on when we follow order of operations, if you were to follow order of operations without the parentheses, then you'd have to do 3 times 6 divided by 3 and then add 6. But that's not what they're asking. They're asking you to take the product, the multiplication of 3 and 6, and then you're going to divide all of that by the sum. So 3 plus 6. So those are just two different ways of writing that problem. And if we we were to answer this, 3 times 6 is 18. 3 plus 6 is 9. So that would give you an answer of 2. 18 divided by 9 is 2. Next example, what is the difference when the sum of 5 and 7 is subtracted from the product of 5 and 7? So they're asking you what is the difference, so that's a subtraction problem, when you're taking the sum, so I'm taking the sum of 5 and 7, I'm grouping those two together, and it says the sum is subtracted, so this is where my subtraction sign is. What am I subtracting from? I had something, switch things up again here. I'm subtracting the sum of 5 and 7 from, because it says subtracted from, I'm taking the sum and subtracting that from product of 5 and 7. You have to pay close attention to the wording. So subtracted from means I got to take it from the second group. So I put the product, which is multiplication, 5 times 7, and I'm subtracting from that the sum of 5 plus 7. 5 times 7 is 35. 5 plus 7 is 12. I subtract my two numbers. 35 minus 12 gives me 23. And there would be our answer for that problem. So just keep in mind, read carefully what they're asking you and start putting the signs in there. So look for keywords like difference or quotient. And then you can see in the first one we had a product, the second one we had sum. So just read it carefully, start putting it together one group at a time. Now here they actually just give you the problem, and we just need to solve it, and then we can check our answer. So here I would write this vertical. So 706, and I would subtract 327 from it. I cannot take a bigger number away from a smaller number, so I need to borrow. So I can't take 7 away from 6, so I need to borrow from the next place over. But there's nothing there to borrow from. I can borrow from 7. So if I take 100 away, I have now 6 left. I add 10 to the 0, so now I have 10 here. Now I can borrow from the 10, and I have 9. Add 10 to the 16, is it a 6? Now I have 16. 16 minus 7 is 9. 9 minus 2 is 7. 6 minus 3 is 3. And to check, all you need to do is add the bottom two numbers. So you do the opposite of subtraction, which is addition. So I'm going to add the bottom two numbers. Make sure that it equals the top number. So 7 plus 9 is 16. 1 plus 2 is 3, plus 7 is 10. 1 plus 3 is 4, 4 plus 3 is 7. 706 right here. That's the same as what I have there, so that's how I know I am correct. Next one is 450 divided by 25. 25 can go into 45 one time. 1 times 25 is 25. They subtract below. 45 minus 25 is 20. Bring down the number, the next digit, 0. 25 goes into 200. Be 8 times. 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. Subtract and you get 0. Now to check my answer, I take 25 times 18. 8 times 5 is 40. 8 times 2 is 16 plus 4 is 20. Put the 0 down because we're now in the 10th place, or 10th place. So 1 times 5 is 5. 1 times 2 is 2. Add my numbers. And I have 450, which is what I had as my dividend. Next part of our lesson is working with properties of addition and multiplication. These properties are ones that you've gone through in the past, so this is just a review. So we have a commutative property of both addition and multiplication. Commutative property, just think of commute, you're moving. So for the commutative property, you're just moving the addends around or the factors around. So here, a plus b is still the same as b plus a. They just switched positions. Or a times b is still the same thing as b times a. So commutative property of addition and multiplication, you're just switching the numbers. The associative property of addition and multiplication, the order of the numbers stay the same. You're just moving the parentheses around a different group. So your association, think of parentheses, you're grouping things together. So here, the first one, a and b has the parentheses around. That's the same as putting the parentheses around b plus c, and you're still adding the a to it. This only works if the sign is the same throughout the whole thing. So a plus b plus c is still the same as a plus b plus c, with the parentheses in a different grouping. Same thing with multiplication. You could put the parentheses around a times b and then multiply by c, or you can take a times the parentheses b times c. You will still get the same answer. The identity property of addition. This means what do you multiply or what do you add to get itself? So for addition, identity property of addition, to get the same number, you're just adding 0 to it. So that's just what you're to prove what the number is. So a plus 0 is going to be a, so it's itself. For multiplication identity, anything times 1 is itself. So the identity property of multiplication, you're just multiplying by 1. And then the last property, 0 property of multiplication, just know that anytime you multiply by 0, the answer is always 0. So let's look at an example here. We want to name the property. So here, 4 times 1 equals 4. Well, it's multiplying by 1, so that's an identity. And we have to say the operation. So identity of multiplication. So I'm just going to put the sign there. You can write out the word multiplication or you can use the symbol. The next one, 4 plus 5 equals 5 plus 4. All they did was they switched the two numbers around. So that's the commutative property of addition. The next one, the numbers are still in the same order, but there's parentheses. And they're grouping it, and the parentheses moves from 8 plus 6 to the 6 plus 4. The answers are still the same, so this is associative property. And associative property of addition. And the last one here is 0 times 5 equals 0. It is an identity because I'm multiplying by, actually not an identity, it's multiplying by 0, so this is the 0 product property of multiplication. And let's look at an example here with putting everything together. So as Lee simplified the expressions 5 times 7 times 8, his work is shown below. What properties of arithmetic did Lee use for steps 1 and 2 of his calculation? So they did all the work, we just need to write the steps. So really it's going to be, what is the property? So they gave you 5 times parentheses 7 times 8. The next step was 5 times parentheses 8 times 7. There is parentheses in there, but the parentheses didn't change. What did change is the order of the numbers in the parentheses. So they moved the numbers, so that's the commutative property of multiplication, because we're multiplying, so the commutative property of multiplication. And then to go from that step to the next step, parentheses around 5 times 8, they move the parentheses. So that's the associative property of multiplication. And then they solved the parentheses first. So they did 5 times 8 to give you 40. And then they multiplied that by 7 to get the answer of 280. So let's do one of these together. There's 2 ways you can simplify this. We're going to do the simpler way. So I know that 25 times 15, that's going to give me a really big number. And that's going to take me a while to figure that one out. So what I'm going to do is I'm going to move the parentheses, or I'm going to rewrite we're going to remove the parentheses and switch the numbers around. So I have 25. I'm going to switch 15 and 4 around. So I'm going to multiply this by 4 and then multiply it by 15. So the property I made use of was the commutative property of multiplication. Then I'm going to put parentheses around 25 times 4 and then multiply it by 15. So I now have the parentheses. I move the parentheses from 25 times 15 to 25 times 4. That's the associative property of multiplication. Now 25 times 4 is a lot easier. So think of 4 quarters. 4 quarters equal $1. Each quarter is worth 25 cents. So 25 times 4 is 100. So we have 100 times 15. So all I did was I multiplied and then 100 times 15 would give you 1,500. And then all I did was multiply on that step. We're just moving them around. You can move them around any way you want. What makes it easier for you to do the math? Maybe you would want to multiply 15 times 4 and then multiply by 25. That would be up to you. And let's look at the commutative property in dealing with subtraction and division. The commutative property does not work for subtraction or division because the answers are not the same. So like if I were to take 100 minus 365, that would give me an answer of a negative 265. But if I were to switch it around and go 365 minus 100, that would give me a positive 265. So the answers are not the same. One gives you a negative answer, one gives you a positive answer. If we did the 36 minus 87, if I were to write this one out and I did 87 minus 36, that would give me 1. 8 minus 3 is 5, gives me 51. But if I go the other direction, 36 minus 87, that's going to give me a negative 51. They are not the same. So you can't use the commutative property. You can't switch them around. And let's do one more problem before, a couple more problems in the lesson. So here we're going to use the opposite operator to solve. So here I have 6 plus x equals 30. I want to solve for x. So the opposite of adding 6 is subtracting 6. So whatever I do on one side, I must do on the other. Make sure you do the same thing on both sides. 6 minus 6 is 0, so all I have is x. 30 minus 6 is 24. So x has to equal 24. I can check my answer because 24 plus 6 does give me 30. The next example, 6y, so 6 times y equals 30. The opposite of multiplication is division. So I'm going to subtract or divide by 6. 6 divided by 6 is 1. So now I just have 1y equals whatever I do on one side, I must do on the other. 30 divided by 6 is 5. So y has to equal 5 because 6 times 5 does give you 30. We'll do the last two, and that would be it. So 12 plus m equals 48. Opposite of addition is subtraction, so I'm going to subtract 12 on both sides. 12 minus 12 is 0, plus m is just m, equals 48 minus 12 is 36. And the last one, multiplying by 12 and n. Opposite is divide by 12. 12 divided by 12 is 1. It just gives me n. Whatever I do on one side, I must do on the other. So 48 divided by 12 will give me 4. So that would be our answer. If you have any questions with this lesson, please let me know and we can go through more examples.